Hello, this is Pablo Cosa from Prescient. In this video, I want to take a deep dive into a pair of related nodes, the split and join nodes, which allow for structures that are similar to map, filter, reduce in some of the programming languages, but in general, in some very interesting operations to be performed on a series of input message structures. So here we are in Prescient Designer, the premier data operations and industrial IoT platform, although what I'm going to say largely applies to stock not read. So for the series of examples that I'm going to show, I'm going to use a very simple data structure. It's a table of car models, the year that we introduced in the market, and I have this mock database node, which returns the price of the car in the message.payload. So it takes an input message.payload, which should be the name of the car, and then it returns the price in the payload. So this simple structure, it's in this car subflow, which just is a simple function node that sets its output payload to an array where each item is an object. And each object has a model property with the car model name and a year property with the year it was introduced into the market. So that's set up for all the examples. So this essentially is this array structure. So going back to here, so the split node essentially goes from one to many, so from one message to many messages. This is also known as serialization. And it depends how it does, what it does. It depends on what type of message or payload it receives. If it's a string, for example, it will one can choose what character to use to split that string into several messages. And obviously, a natural splitter would be the carriage return or the new line, which is typically what indicates the end of a line. So it's sort of natural for strings to be to use that, although one can choose any other character that makes sense and put it here in this option. The array, if message payload is an array, by default, it will just take each item of the input array and then generate a message out of that item. But one can also have essentially subarrays by choosing a larger number than one in this field. And if it's a message payload is an object, it would actually take each key and split it in keys, essentially in key value pairs. And one has an option to copy the key that is going to be used in each message and put it in another property too. And we'll see why that might be actually convenient. So that's essentially a super quick overview of the one-to-many or split node, and its companion, the many-to-one or a join node, has three modes of operation: automatic, which is what I'm going to be showing first, then manual and reduced sequence, and we'll cover those in a little bit. But for now, let's just set it to automatic, which is the most convenient node. So one of the operations that one can do is just filter. Filter this example, for example, this table. I want to filter it only work on cars that were introduced, say, since 1950. And so in this case, I would filter out the Model T. So one way to implement the filtering in a low-code way is just use a switch node. Since the input structure is an array, the split node is going to generate a message for each item of the array, and each item would have an object with model and year properties. So by using a JSON add expression that says a message of payload a year should be greater than 1950, the switch node only will generate an output when the input message has a car that's been introduced to the market after that year. And then the resultant messages will be reassembled by the join node, and we should see essentially the payload of at the output of the join node should be an array of car objects that where the cars should be the ones introduced after 1950. Now, one really important point to note is that the way the split and join noise work in automatic mode is, if you look at the very detailed documentation of the split node, the magic happens because the split node generates this part object, which has a whole bunch of properties, which you can read in the documentation what they do. But essentially, the most important one, or perhaps one of the most important ones, is the count, which essentially tells the join node how many messages to wait to generate an output message. Now, almost by definition, if we're filtering in the middle between the split and join node, it's natural to think that in many cases, the messages going into the join node will be less than the ones that we started at the input of the split node. Meaning, in this case, we started with 5 cars and we'll filter out 1. So obviously, the count that the join node has to wait for has to be modified. And not surprisingly, the switch node has this option, which I selected, which is recreate messages sequences. So essentially what it does is it alters that count produced by the split node so that it matches what it's filtering. And so everything works as you would expect. So if we turn this debug node up, we should see the output, and the output should be only 4, which is the cars whose year of introduction was past 1950. So the key message here is if you're filtering, just if you use the switch node, it has that option that's very convenient. If not, you would have to go into the message or parts count and alter that accordingly so that the join node produces an output when it should. So another option is to just, instead of filtering, one can do any other sort of mapping operation. In this case, let's just look at prices. And so what I want to have is add a price field to that input structure that I showed in the beginning, which is model and year. I want to add a price property. So this mock database node takes, as I mentioned, a car name and message of payload, and it returns its price and also in the message of payload. So the serialize, split node, essentially it's just stock options. So it's going to take each row and serialize it as the filtering example that we just covered. Because of the idiosyncrasies of this database node, which operates on input and output payload, this now essentially I'm copying the payload to this temporary property of the message, and because the change node rules are applied sequentially, so I copy the payload to this temporary property, and then I replace the payload with the car model so that we can get the price. And then on the other side of the database node, I copy the payload, which should be the car price, to the price property of this temporary message property. And then again, since these rules are evaluated sequentially, now I copy the whole message property to the payload. So then it goes to the join node, which is set to automatic mode. So at the output of on this debug node, we should now see 5 items on the list, and each should be an object with model, year, and price. So if this works as expected, we see the 5 objects with the price property appropriately added to each item of the array. So that's the mapping function. The split node behaves differently with different types of message payloads, because I think the data can come in different with different structures. So it's just more convenient if we have all these options, so that regardless of how it is coming into the split, it's likely that we can use one of these and operate on the data in a low code fashion. So let's just say that now we're arranging the data so that it comes as key value pairs. In this case, the split node is set so that if it's an object, it's going to take each key and split it in key value pairs, and also copy the key to this message.model property. So if we transform the data from a list or an array to, in this case, an object which has the keys of the object are the name, the model of the car, and the value of that key is the year it was introduced into the market, then if we then so that I copied the key, which is the name of the car, to the model property, so that then I can set the payload to that, so that it goes into the database node, looks at that payload, fetches the price, puts the price in the payload, and here, because the split node looks at the actual when it's split in an object, it looks at the payload and makes that the value of whatever key that message corresponded to. Then we don't have to do anything here, and there's no post processing after the database node. If we now run this, we should see the payload should be an object where the keys should be the names of the cars, and the value of that key should be the price. And so it goes. Something to note here is that when I was serializing or transforming the array of objects into an object with key value pairs, notice that I set the value of this of each card to its year of introduction to the market, but because the price goes into the payload could have been anything. Because I didn't know, it wouldn't matter, right? So what matters is that there's each message is associated with a key, and then whatever payload that key is associated with at the time it goes into the join node, that's what's taken to generate the joined node output. The final mode, automatic, or actually I shouldn't say that. The second option of the join node I want to cover is the reduce sequence. And this is essentially a low-code way of implementing the reduce function that is present in Node.js and JavaScript and many other programming languages. So to level set everybody, essentially, if one has an array, a reducing function is a function that's going to operate or perform the same operation on each item of that array, but that function has the option of using one value that is a function of the previous operations on that item. Perhaps an example will make that more clear. If we set that history value, so to speak, to say initial value of 0, then we can apply this function. We can add the $A, which is this accumulator or history value, and add that to the message of payload. And that would be the history accumulated value for the next item. So, so for item 0 of a list, $A will be 0. For item 1 will be the payload of the previous item. For the second item will be the sum of the first 2 items, and so on and so forth. And so that will, this function with the accumulation will happen on each item of the array. And at the end, once all the items on the array have been operated on, then we have the option to have a fix-up or a post-processing expression. In this case, the $A, which again is the cumulative value, just given the expression I have, it's essentially the sum of all the payloads of that array. It's going to be divided by $N, which for the join node, that means the number of items on the list. And how do I find out if it's $A, what $A and $N mean, and how do I even know they exist? Well, as many of the stock array nodes, they have very good documentation. And you can scroll down to the reduced expression, and you see $A, $N. During the reduced expression, you can also use $I, which is the index or the position of the item that is being operated on, if that is relevant for computations. And for the fixed expression, you have access to $A and $N. So this is going to take, essentially, this reduce sequence is going to add all the items on a list and then divide it by number of items on the list, which is not what I'm saying. It's another way of saying it's going to calculate the average. So if I just serialize the cars with the stock options of the split node, meaning it's going to take an array and it's going to ship and create one message per item of that array. And if I put the model name into the payload, it's going to go into the database node. It's going to calculate the price, and then it's going to calculate the average price with the join node in its reduced mode. So if we run this, we get the average price. So those are the automatic mode of the join node and the reduce mode. The join node is very convenient to use with the split node because, as I said, the split node generates this message of parts object, which has all the different properties to make all this magic happen with minimal work from us. However, if for whatever reason the split node cannot be used or it's not convenient to be used, one can also use the join node in manual mode. So in this case, the options are a little bit different. In this here in this example, you can create all sorts of output types, but I'm choosing to generate a key value output object combining the message of payloads that it's being received. And the key here is that the join node in manual mode knows to produce a output message when it receives a message complete, or sometimes if there's a fixed count that every, say, if I put a 5 here, every 5 input message is going to generate an output message. Or if you can also have a timeout, so if so every 5 seconds maybe can generate a message. For this example, essentially it's going to wait, the join node is going to wait till it receives a message dot complete. The key take-home message here is that the value of message dot complete, it doesn't matter. So message dot complete equals false is the same as message dot complete equals true. So the message dot complete property cannot be in a message until the last one, or until we want to produce an output message. And I'll show you what I mean. So same database node, join node in manual mode. And here I'm just going to serialize the cars in this fashion. They're going to have a model property and then a payload, which is the car model again, so that we can fetch the price. And if it's the last message on the array, then complete is going to be set, and it's going to set to true. Again, it could be set to anything. But it really doesn't matter. So So this node is going to send 5 messages. The last one it's going to have a complete property, and the join node is set to collect all those payloads and generate a key value pair using the model, whatever is on the message of model, as the key. So as I said, I'm serializing it by putting the car name in the model property. So we should see something similar to what we saw in the automatic mode, where the payload is an object, where the keys are the car names, and the properties, the value of those properties are the prices. So here you go. So car names and prices. So one thing that, one final remark is that you need not have the complete property set to anybody in the last message of the sequence. You can also send all the messages of the sequence with no complete property set, and then send a message which has an undefined payload, but a complete property set. In that case, the payload is ignored, and then output message is produced by the join node. So in this case, it's similar to what we had in the previous example. It's taking each message in the car array, sending an output message with a model property with the car name and a payload, with also the car name, so that the database node can fetch the price and put it in the payload. But I'm sending 5 messages, and then I'm sending a message which has no payload, i.e. the payload is undefined, but with a complete property set. And so we should have the same output as before. And there you go. So that's what I had for today. Let me know if anything was not clear, if you want to see more of this in the comments below. And if you have any suggestions or ideas as to which nodes you want to have covered in depth, let me know also in the comments below, and we'll do. Thank you very much.